Okay, my friends, this video's subject is going to be how to rotate a graph. And the reason we're doing this right now is because your semester project to create the cartoon character, a lot of you have some mostly elliptical type shapes that are not centered. They're not perfect left, right, up, down. They've been spun a little bit. In other words, your X radius isn't going straight side to side. So go ahead and write this down and get it on paper so that when I switch screens, you'll be able to refer back to it. What we're going to do is take out the x and put in these other expressions. We're going to put in x cosine theta plus y sine theta. And I know we haven't really done trig yet, but this is, I'm giving credit to Miss Draper for this one. We had this problem and she went home and researched it and figured out how to rotate the graph. You replace y with what's given here, and multiplying these terms by sine and cosine is going to spin the graph around. And we'll talk a lot about trig next semester, but you know you've done sine and cosine when you did right triangles, SOHCAHTOA, and that sort of thing. But this multiplication is going to help us spin a graph. So let's start, let's go into Desmos. So this is the problem we are having. So let's say I have an ellipse that's here, but I need it to be tilted. So one approach, this equation over here, is the equation that has it's in the ellipse form where it's centered at 2, -3, x radius 3, y radius 6. And so my first suggestion was, well, let's throw in an xy term. So because we learned the other day that the xy term is the term that makes it rotate. So if I put in something like, let's say k xy, and I make k my slider, see, if k is 1, my graph is already, oh, excuse me, hang on just a minute. Okay, so I had an uppercase x and y, I needed lowercase. So here's my equation. I've put in kxy, and I've made k a slider. So you can see what happens to my ellipse. When k is 0, that's what I already had. Here's the ellipse that I started with. If I put in that xy term, I can make it a slanted ellipse like that. But the problem is it changed its size. You can't just put an xy term in without messing up the center and the radii. So that suggestion really wasn't helping people because a certain value, it makes it an ellipse slanted one way, but it's a lot skinnier. It makes it an ellipse slanted the other way. It makes a hyperbola. There's one specific case where it's a parabola that we talked about the other day. But one way or the other, this is not going to take that ellipse right there and tilt it the way we wanted to. We would have to mess with all of the other characteristics of the ellipse. So that one's out. Let's just get rid of this. So another option that I thought of was just go back to the quadratic relation, the ABC. I didn't use an E because I think Desmos recognizes that as E, the base of the natural log. But I thought, okay, I've got a tilted ellipse somewhere on this graph. Certain values of A, B, C, D, F, and G should make that work. So I just put them in, made them all sliders so that I can slide back and forth and see what I can come up with. So you start changing those, and it goes from different shapes. It's tilted different ways. Sometimes it's an ellipse. Sometimes it's a hyperbola. Again, it could be a parabola. But this one was even more difficult. I couldn't get the size and the tilt right. I just keep changing between different shapes. It's almost impossible to have a picture of your ellipse on there and match it up with this by sliding these. Okay, so in comes the fixer, Miss Draper. Let's get rid of this graph and let's practice her formula. Get rid of all these old sliders. So I want to just practice on a simple graph like y equals x squared. This is something I might have learned at some point in my life, but it's been way too long for me to remember it, so I'm thankful she did this. Remember her formula. We're going to replace x with x cosine theta plus y sine theta, and y with negative x sine theta plus y cosine theta. Okay, so let's start with the y on the left of this equation. Negative x sine theta plus y cosine theta. I literally need to take out the y and put in all of this stuff. So this y right here, I took it out and I put in negative cosine 30x Okay, forgive me for that little hiccup. I needed to adjust my graph in Desmos. What I did is I took this y out and I replaced it with negative x sine 30 plus y cosine 30. You need to put your sine of 30 and cosine 30 in parentheses. Otherwise, I think Desmos will take the sine of everything that comes after it and it can make a big mess. Also, make sure on your settings over here that you are in degrees if you want to talk about rotating it in degrees. So then I replaced my y, and notice over here my x. My entire x was in parentheses, so I'd have the entire set of parentheses squared. And in place of this x right here, I put x cosine 30 plus y sine 30. So there's a lot of stuff in here afterwards, but it's a simple substitution. Take out y and put in all of this in its place. Take out x and put in all of this in its place. And what happens is we get this same graph, but it's been rotated 30 degrees. So this blue graph is a 30-degree rotation of my original red parabola. All right, so now let's apply this to our cartoons. So I'm working on Marvin the Martian. And I see this little black ellipse down here that doesn't appear to be it's been tilted. So what I need to do is create a tilted ellipse to trace over the outline of this little black shape right here. Okay, so let me get an ellipse in place that is about the right size and about the right center, and then I'll get that and be right back. Okay, so here was my first try at it. I picked the center to be negative 0.7, negative 4.1, x radius 0.15, y radius 0.05. So it's pretty close. I think I'm going to make it a little bit taller, make that 0.07, and I'm going to make it a little bit more to the left. So instead of x plus 0.7, I'll make that 0.8, maybe too much, let's call that 0.75. Maybe a little better. I can still tinker with that in a minute, but let's tilt it now. So I think that the major axis of my tilted parabola is probably like 15, 20 degrees up. So what I want to do is that substitution where I take out my x's and I plug in x cosine theta plus y sine theta. I'm going to take out my y's and plug in that substitution. The only difference between what we're doing right now and what we did with that parabola is everywhere that I see an x, I need to see x plus 0.75. So I'm going to replace that x right there. I'm going to actually do this again so we can see the one I started with. The x plus 0.75 that I have right there, I need to replace that with x plus 0.75 times the cosine of the number of degrees that I want to rotate this thing. So I'm thinking I'm going to rotate it about 10 degrees up. So I'm going to put cosine of 10, and I'm going to do plus y sine 10. But again, whenever I see a y here, I need to have a y plus 4.1. So there is the changing of x to x cosine 10, y sine 10, with my x and y both adjusted. Now this y over here, I need to adjust it. I need to make it negative x sine 10 plus y cosine 10. So let's do negative x But there's the x plus 0.75 again. And what's really cool is if you notice the graph as I make these changes, it produces some really cool, funky looking graphs. So there's negative x times sine of 10 degrees plus y cosine 10. All right, so it wasn't much. It was only a 10-degree rotation, but you can see the difference. I'll change this one's color, make it blue. Okay, so if we zoom in here, what I've created, and the good thing about this way is I don't move the center around. My other two tries at it were moving the center and changing it to a hyperbola and all sort of weird stuff. What I have now is an ellipse that's in the same place but tilted. All right, that's why you have to keep all your x plus 0.75s the way they are. So now I can adjust it some more. Let me get rid of, not fully get rid of my red one, but just turn it off for a minute. So now I can look at this blue one and see how it matches. It's not bad. I think it needs to go a little bit right and a little bit up, but I think my radii are pretty good. And I realize it's so blurry that because we're zoomed in so far, it's not going to be 100% perfect just due to the graphics. But let's move this thing a little bit right and a little bit up. So my x plus 0.75 moves this thing left 0.75. So what if we made it 0.73 here and here? 0.73, maybe that might be a little better. What if I move the whole thing up? Instead of minus 4.1, what if I do minus 4? 4.0. Whoops, that wasn't good. So you can see that you're tinkering with it as you go. So I don't want to move it all the way to 4. Instead of negative 4.1, let's do negative 4.05. See what that does. Still too much. This is some tiny units we're dealing with. Still too much. Oh, I think I was going the wrong way. 08. 08. Get the picture. So I've got it tilted and I've got it approximately centered, but there's going to be some maneuvering you have to do. If you want to change the tilt, let's say I thought it needed to be rotated like 12 degrees instead of 10, then I could change all my 10s to 12s. You have to change them all to keep everything consistent. And of course it disappeared. What was that? That was cosine of 12. There we go. All right, so there we go. We've got a way to rotate any graph without changing its shape and without changing its center and radii. Awesome. This is amazing. I'm so happy. All right, so what you have, final result, is a little tilted ellipse that traces out that one. Thank you, Miss Draper. Hope you've enjoyed it. It's the best video I've made all year. Young out.